My dear students, welcome to BYJU'S Exam Prep. Hope you guys are fine. So come on guys, join the session soon. Faster, faster. Let's be quick. Good evening, Vipul, Struggle. Good evening, everybody. Okay, so I guess you guys are good. So today we'll be solving questions of hydrology and irrigation all together. So guys, any doubts by the way from environment? Any doubts? If it is, let me know that also. Okay. So after that, let me tell you some things that there is a scholarship test which will be going on 24th December at 8 p.m. So if you guys are interested, you can register yourself. It is just free of cost. You don't have to pay a single penny for it. Okay. Hello Swapnil. Hello Rajneesh. Hello everybody. And one more thing I have to tell you that if you haven't started to give test series, you have to give it. And there is mock test, there is subject wise test. If you're willing to give, you can give. The test link is in the description. And what all things you'll be getting in the test is the detailed mock analysis, scientific calculator, your rank, everything, and more than thousands plus practice questions. Okay. Thank you, Rajneesh. At least somebody gives me a compliment. Thank you. Okay, fine. So, after this, last but not the least, you can join my Telegram group if you have any doubts, and my upcoming classes, everything is mentioned in that. Okay. So that's all. Before that we move further, if you want to download, you can download GATE preparation ebook. Link is in the description. You can go through it. Okay. First thing you will be telling me that there are 15 questions, as you know, which I'll be dealing, and 15 questions will be homework, and I'll be providing you the answers. Remind me, I am like nowadays I'm becoming like busy with work, so I forget the things. So set me a reminder, okay? And first of all, tell me 30 minutes or 45 minutes, what is our target? Or 60 minutes? 15 questions, what will be the target? 30 minutes, 45 minutes, 60 minutes? Come on guys, tell me fast. What should be our target? 30, 45, 60. Come on guys, faster. 30 minutes? Okay. So let's take a target of 30 minutes. Okay? Fine. So everybody ready? With a heart sign or with a thumbs up sign with high Josh, guys. Ready everybody? It's 9. I think you had your dinner. So now you have to be with extra Josh ready. 30. We should take a lower target so that at most if it extends to 45 minutes. Okay? Let's try. Ready everybody? Come on guys. No Josh at all. Come on, faster, faster, faster. Ready? Okay then. Fine. Struggle is ready. Why you put your name like Struggle Life Wala? From where do you get these names? I don't understand, guys. Okay, fine. So it's approximately it is 9:05. So we should try that max to max 9:45 and at most 10. But let's not target 10. Let's just target around 9:45. Okay? Safe limit 45 minutes. I think 30 minutes, then it should extend maximum to 45. Okay? So that's like we do it in environment, acceptable limit and then cost for rejection limit. So come on guys, start. This is your first question. We are starting yesterday your fluid mechanics question and ended on 181. So we are starting from 181. The observed peak. Now see this question because maximum students get confused in it. Okay. The observed peak of flood during a 4-hour storm of 8 centimeter rainfall was 500 meter cube per second. The average loss rate was 10 mm per hour. Base flow was 50 meter cube per second. If there is a rainfall of 12 centimeter in 4 hours on the same catchment, then what will be the discharge? Come on guys. See, first of all, it has given me peak flow, which is 500 meter cube per second. So if I want to get the peak of direct runoff, so I have to subtract base flow, which is 50. So 450 meter cube per second. Is it? Like this only we have to do it? Peak of flood hydrograph minus base flow. But right now, what I get is the peak of direct runoff hydrograph. I want to get the peak of unit hydrograph for 4 hour storm. So peak of unit hydrograph is always peak of direct runoff hydrograph. This you have to know it, okay? This is very, very important. So peak of unit hydrograph is peak of direct runoff hydrograph divided by rainfall axis, which is in centimeters. Remember this, okay? Now, peak of direct runoff hydrograph is 450. Don't put 8 centimeter as the rainfall axis. Why? Because it includes the loss also. So, first you have to subtract 8 centimeter minus 10 mm means 1 centimeter. 1 centimeter per hour. And the rainfall took place for how many hours? 4 hours. So, 4 centimeter. How much it is coming? 4 ones are 4 again. Just check it out. This is the peak of unit hydrograph for 4 hour storm. In the question it is asking me if there is a rainfall of 12 centimeter in 4 hours on the same catchment, then discharges. Come on guys, there is important thing which you need to know. And that is we have two main assumptions in the case of unit hydrograph: time invariance and linear response. See, if for 4 hours 8 centimeter, technically 4 centimeter is the effective rainfall, we have 112.5 meter cube per second of discharge. So when there is a 4 hours of rainfall, duration is same but the rainfall excess is different. What will be the discharge? So for 4 centimeter, if we calculated the peak, we got 112.5. 12 centimeter of rainfall is there. What will happen? Loss will remain same because the same catchment it is talking about. 1 into again 4 hours of rainfall. This time rainfall excess is 8 centimeter. See, I got the peak of unit hydrograph. So for 1 centimeter of rainfall, this was the discharge. For 8 centimeter of rainfall, how much will be the discharge? So what do you have to do, guys? What do you have to do? Just multiply. For 1 centimeter, if 112.5 meter cube per second of discharge is there. For 8 centimeter, how much will be the discharge? Just multiply. Same thing, but this time peak you already know and this time is 8 centimeter. This is direct runoff hydrograph. Base flow also you need to add, which is 50. Calculate and tell me how much it is coming. Calculate and tell me fast. 112.5 into 8 plus 50. This comes out to be 950 meter cube per second. So initially it was how much? Initially it was 500. Now it is 950. Remember, we are comparing the flood hydrograph. Initially it was 500. Now it is 950. So how much increase is there? Increase is there by 450 meter cube per second. Any doubts? Let me know fast. Oh, Abhinav sir is also there. Good evening, sir. I was to inform you that, So 10:45, there will be formula memory test will be there. And actually, as you know, all faculties frame their own questions. Similarly, Abhinav sir has framed some you will be super excited because that questions are brainstorming questions. And the session will be at 10:45 p.m. Link is already there. You can go and set a reminder so that you don't miss the session. Okay, see, got this? Clear? Good question. Now, next question. As if I am only solving the questions, what about you guys? Data analysis on maximum one-day rainfall depth at Hyderabad indicated that a depth of 260 mm had a return period of 50 years. So, recurrence interval is given to you, 50 years. The probability of one-day rainfall depth equal to or greater than 260 mm at Hyderabad occurring 2 times in 15 successive years. So it will occur exactly 2 times, not greater, not anything like that. Exactly 2 times in 15 successive years. So 15 C2. The probability of occurrence is 1 upon T. The probability of non-occurrence is 1 minus P, that is 1 minus 1 by T, that is 49 by 50. So, favorable event. How much it is coming? Come on guys, you have to solve it and tell me. Every time I am the one who is telling. Faster, tell me fast. Tell me in percentage. See, struggle, this mistakes you do. They see, live example. Now you also understand from this mistake. I told you now when it is an NAT question, last line is damn important. See, it is given in percentage. You wrote it in decimal. You did it. If you are doing it in your virtual calculator, how much pain you take. And if you don't read the last line properly, you will do that mistake. Now tell me in percentage. That's why when you go to the examination, ma'am told to read the last line properly in NAT questions. How much it will be? It has asked you in percentage. 3.2222 it is coming, so it will become 3.23 percentage. So your answer was correct. Only the thing which you made mistake is you haven't converted it into percentage. Come on. This question faster. See everybody. 0.030 percentage? Is it? Just let me check it out. Or you guys have made the mistake. I think so. Because I wrote it in the form of decimal, you need to multiply with 100 also. 15 1 by 50 square. It is coming 0.0322. It has asked in percentage, so you have to multiply by 100 beta. What is this? Okay. This question. Around 10-12 minutes, we have done 2 questions. Buck up. The evapotranspiration rate from the land and the oceans is given to us separately. The amount of atmospheric water is given to us. We have to determine the residence time. Residence time is average time taken by the water molecule to pass through a particular phase of hydrologic cycle. So let's talk about residence time. How much it will be? Residence time. Volume of water, total flow rate. Can we solve it? Volume of water is given to us directly in the question. Come on guys, volume of water is given to us how much? 18,000 kilometer cube and flow rate. If you don't know, if you haven't studied that topic, then also you can solve it. Only you need to do is go through the units. See, it has asked me time. I didn't know, if I don't know the formula also, then I'll also solve it. See, I'll get the answer in year. Now again, determine the residence time of the water molecule in the atmosphere in days. It is asking you in days. So first you will get it in year. If it is not specifying you whether it is a leap year or anything like that, multiply by 365 by default. Okay, solve this. How much you get? And for getting it in days, just multiply by 365. Got this? Clear? So as simple as that. As simple as that. Come on. Moving towards the next question. Yeah, this is a good question. Every question is good only. So it has asked you to calculate the depth of water in the root zone. See, remember, this has 2 questions. Okay, I have taken it here. This is 2 questions here. It has asked you to calculate depth of water in root zone at field capacity also and at permanent wilting point also. See, depth of water in root zone at field capacity and at permanent wilting point is 0.3 meter per depth and 0.7 meter per depth. It is asking you depth is given to you at field capacity and at permanent wilting point. It is asking you to calculate field capacity and permanent wilting point. They can ask you MSQ, or if they want they can ask you NAT, the difference between field capacity and permanent wilting point. If they ask you, then also what you have to do? Then also you have to do what? You have to calculate field capacity and permanent wilting point. In the last question, you are getting 0.03076. No, you are not getting. This you have to multiply by 100 for getting it in percentage. Swapnil, you have to multiply by 100 for getting it in percentage, beta. This is, you will get the answer in decimals right now. So for getting it in percentage, you need to multiply by 100. Clear? This one you were talking about, no? Or this one you were talking, huh? 0. Which other question? On which question you are talking about? This last question also, I'll check it out. 18,000, 82,000. Triple zero is there, no? One more zero is there. 0.0311. It is also coming correct. 11.38. This one you are talking, this is also correct. This is also correct. It is 82, no? 182 is not written, it is 82. It is correct, beta. I checked it. Anybody just check it again? Come on. The depth of water in root zone at field capacity and at permanent wilting point is given to you. Depth of water when it is at field capacity is given to you. Per meter depth of soil, and depth of water at permanent wilting point is given to you as how much? 0.7 per meter depth of soil. Now it is asking you the field capacity and and the permanent wilting point. How you'll do it? Faster, faster. I checked it. It is coming that only, Swapnil. Everybody else also check it. I did it. It is coming 3.223 only. First it was coming point something. So if you want to get it in percentage, you multiply by 100, na? Just tell me the answer for this, everybody else. You have to calculate field capacity and you have to calculate permanent wilting point. So gamma W, how much you will take? Not mentioned, 9.81. Gamma D is given to you 13. Depth of water in the root zone at field capacity is given to you 0.3. And this is 1 meter. How much it is coming? Field capacity and permanent wilting point. As simple this question. Sometimes the questions appear tough, but the questions are super easy. So gamma D is 13. Depth is again here 1 meter. This is 0.7. Tell me how much is the field capacity? Faster, tell me the field capacity and the permanent wilting point. See, now here also, Swapnil, initially it will come out to be like 0.2264. But if you want to get it in percentage, you will multiply by 100. You will get it as 22.64 percentage. Clear? Okay. Now here when you solve it, permanent wilting point, initially you will get it in decimals. How much it is coming? 0.5277. So this is 52.77%. Okay. Got this? Simple. 0.538. Just let me check it out again. Point 0.528. Yeah. 0.528. So this will be 52.8. Okay. Let me check it out here. 15C2. Okay, fine. I'll do it again. 15C2. If you are so much confused, let me do it. 1 by 50 square into 49 by 50 to the power 30. 0.032298 it is coming, beta. If I want to get it in percentage, I'll multiply. I will get 3.229. The calculation is correct, Swapnil. I did it. I checked it again for you. Okay. This question. For a crop with growing season of 2 months, okay, 2 months, it has given me what is the mean monthly temperature and the percentage of sunshine hours. It is given to me. Okay, the cumulative effective rainfall. So effective rainfall of both the seasons it has added and it has given you. It has given you consumptive use coefficient, consumptive crop coefficient, basically 0.75 it is giving to you. Leaching requirement is given to you. It's a good question. Okay guys, check it out. So find the net irrigation requirement. If it is asking you to calculate net irrigation requirement, how much it is? It is consumptive irrigation requirement plus leaching requirement. And consumptive irrigation requirement is consumptive use minus effective rainfall plus leaching requirement. If you don't know this thing, you won't be able to solve the question. Firstly. Secondly, I know effective rainfall, how much it is? It is 5.3 centimeter. I know leaching requirement, how much it is there? 3 centimeter. What I don't know is consumptive use. I have to add the consumptive use for September as well as October month. So here I have to go through the formula because here monthly percentage of sunshine hours is given. I'll be going through the formula of Blaney-Criddle method. Okay. So I'll add both the Kp by 40, 1.8 T plus 32 where the temperature has to be substituted in degrees Celsius. Okay. So what is the crop factor? I have to pick it out. It is 0.75. Percentage sunshine hours for first one is 6.8. 6.8 by 40. 1.8. Temperature for the first one is how much? 22. Remember you have to substitute it in degrees Celsius. Plus 32. Plus 0.75 into divided by 40. Here the percentage sunshine hours is 7.4. 7.4. 1.8 plus 32. See, don't expect that they can't ask you such questions. They will ask you. Remember it. Okay? Challenge. I did the calculation. It might see human errors can be there. I'm not like challenging, but where it is fine. Everybody solve it. Okay. So if I'll win that 500 rupees, then what I have to do? That struggle. Tell me that also. So how much you'll get by solving this? Why you will say, ma'am, why you added it? Because beta, effective rainfall cumulative is given for 2 months. Everything is given for 2 months. So that is the reason for calculating consumptive use. I'm adding it for 2 months. How much I'll get it? Come on, guys. Solve this. Now, Swapnil, everybody, Vipul, be fast, beta in calculation. I don't think right now you are doing in virtual calculator. Just check it out. It might be incorrect also. Calculation mistake, anybody can do it. Okay. I also have a calculator, but then also mistakes are mistakes, right? So check it out. This is only you're getting. Vipul, Swapnil, everybody. This one is you're getting. Just tell me faster, faster. 18.059, that is 18.06. Correct. Got this? That's it. That's it. This logic and this thing. That's it. The whole question is solved. See, they can ask you field irrigation requirement. They can ask you gross irrigation requirement. If they ask you such things, they need to give you water application efficiency. They need to give you water conveyance efficiency. What is the net irrigation requirement coming? 15.76 centimeter. That is option B is the correct answer. Okay, fine. This question. Come on, guys. This questions. Again, they can ask you such sort of questions. Remember the formula and everything you need to remember. That's it. See, The watershed, one is 2 kilometers square. It has different runoff coefficient. Another is 3 kilometers square catchment area is there. It has different runoff coefficient. It is asking you to calculate peak rate of runoff. So if it is asking you to calculate peak rate of runoff, the formula for it, if you want to know the formula, it is 1 by 36 kPCA, where K is runoff coefficient. This is critical rainfall intensity in centimeter per hour. This is the catchment area in hectares or kilometers square. Hectares. Okay. Now, here actually it has not given me runoff coefficient directly. What it is giving me, it has given me in parts. Like this 2 kilometer square area and this is 3 kilometer square area. Both are different runoff coefficient. So first I have to calculate equivalent runoff coefficient. The formula is K1A1 plus K2A2 divided by A1 plus A2. So this is 0.2 into 2 plus 0.7 into 3 divided by 5. 2 plus 3, 5. How much it is coming? This comes out to be 0.5. So one thing I got, that is the K value, how much it is? 0.5. You can check the calculation, okay? Critical rainfall intensity, firstly, it is not given to me directly. I have to do it by interpolation. Catchment area, it is given to me as 47.65 minutes. If it would have been given me 55 minutes, 57.50, such sort of things, I would have directly substituted the basically 10, 20, 30, 40 minutes, anything like that it would have been given. So I would have directly got the rainfall intensity. But 47.65 lies between 40 and 60. So I have to calculate the rainfall intensity. So what I have to do, I have to go by interpolation. So critical rainfall intensity. How we'll go? 60 will be there. I am doing it at a single stretch. If you want, you can do it other ways. How you do interpolation, that is up to you. You can do it in any manner. 60 minus 40 is 20 into 47.65 minus 40. So this is 7.65. So I am doing it like this. आज मेरा data समाप्त हो गया. If you would have been living in my area, I could have given you my Wi-Fi, Arun. Where it has gone? Come on, guys, solve it. That's why I was thinking, where is Arun gone? Come on, guys. Rishabh is there because Rishabh is also not replying today. Solve this. How much it will come? It will come in mm per hour. 61.9 mm per hour. When you want to substitute, you have to substitute it in centimeter per hour. So 1 centimeter is equal to 10 mm. So this time we have to divide it 6.19. See, the area is 2 kilometer plus 3 kilometers. So the total area comes out to be 5 kilometers square. As you know, 1 hectare is equal to 10 raised to power 4 meters square. Similarly, 1 kilometer square is equal to 100 hectare. So 5 kilometers square will make how much hectare? 500 hectares. Solve this. As simple as that. Okay, library is closed today. Why? Anything special? Solve this, guys. Swapnil, everybody. Just check it out. So, oh, Rishabh is there. I thought he is not replying today. Whenever Rishabh name comes, I just remember that cricketer Rishabh Pant, wicket keeper. Okay, fine. Solve it faster, faster, faster. See, if you will take time in calculator, then how much time you will take in virtual calculator? Fine. This is the one you are getting. Okay, check it out. Swapnil and everybody, Vipul. See, I told you the concept, calculation, I leave it to you. And as I told you, free gate workshop is also going on. You can register yourself and attend the workshop. This is very simple. 1 minute is more than sufficient for this question. 1 minute, that's it. The ratio of average values of shear stress produced on the bed and banks of a channel due to flowing water is produced on the channel bed and the banks of the channel. Come on, guys. Okay. Fine. कल देख लेंगे. And if I do it private, Arun, then ratio of average shear stress values. Come on, guys. On the bed, the value is gamma WRS. On the banks, it is 0.75 gamma WRS. So this 0.75 is 3 by 4. So if it is goes on the top, it will become 4 by 3. 4 by 3 is greater than 1. So the answer will be greater than 1. Don't you think they can ask you in 1 marks questions? Of course they can ask you. Correct, Arun. Fine. How can we leave this question? Floor thickness. Just the formula, that's it. Just the formula, that's it. Floor thickness. 4 by 3 Hg minus 1. Specific gravity minus 1. Head H, it is asking you, it will be the piezometric head at the bottom of the floor. It is given to you 10 meter. Datum you will subtract and the difference, that is 2 meters. So this will make how much? 5 meters. That's it. Simple question this is. Very simple question. Oh, got the answer. You are telling me for this question, C or the previous question? It is coming 4.4444 like this. So approximately this is C option. Okay. This question is database, guys. Again, it can be asked for 1 marks. It is asking you to calculate number of rain gauge stations for an area of 100 kilometers square in hilly and heavy rainfall. So first you need to know the density. If you don't remember the density, this question you cannot. Yeah, they should specify 144 पे देख रहा हूँ. Okay. Factor of safety, yeah, they should have specified that. If it is not, generally we don't take. Right now I have taken, but they should specify, Rishabh. I agree. Okay. Now for this question, you need to know what? You need to know the value. Hilly and heavy rainfall areas. I am telling you, hilly density you should know. And heavy rainfall area. One station per 130 kilometers square. Okay, so if one station for 130 kilometers square, how much rain gauge stations is required for 1300 kilometers square? Come on, guys, now you can do it. It's just the unitary method. Very good. That's it. 10. This is an MSQ question. You have to calculate the leaching requirement. You have to calculate the depth of water required for irrigation. Come on, guys. Faster. For irrigation water, it is given to us 1.2 millimole per centimeter. For electrical conductivity of drained water, this is twice the electrical conductivity of irrigation water. Yes? Am I correct? I think I am wrong. I am wrong. That is correct. 131 is correct. This one. This is 2 into ECA. And electrical conductivity of the saturated extract is given to me, which is ECA is given to me 10 millimole per centimeter. Electrical conductivity of drained water is twice into ECA. So 2 into 10, that is 20. Clear? Now what it has asked me? It has asked me two things. First thing, it has asked me leaching requirement. What is leaching requirement? Again, you should know what it is. Electrical conductivity of irrigation water, electrical conductivity of drained water into 100. So irrigation water, it is 1.2 millimole. Just check the units. Millimole per centimeter. It is 20 into 100. How much it will come? See, 21s are 25s are 1.2 into 5, 6%. Simple. So leaching requirement is 6%. If I am going fast or if I am going slow, let me know. Okay. Now again it has asked me how much water is required for irrigation. So what I can write, leaching requirement is depth of water required for irrigation minus consumptive use upon depth of water required for irrigation into 100. So 6% depth of water required for irrigation I need to calculate. Consumptive use is given to me as 80 mm di into 100. How much it is coming? You will get the answer in mm. This will come out to be 85 mm. Just check it, huh? Clear? Fine. So it's around 35 minutes of hours. No, we started at 9:05, no? So approximately 30 minutes. Fine. Yeah. This question is something. How can we forget root zone question? Huh? This is a good question again. Mark it that you have to solve it. Moisture holding capacity of a soil in an 80-hectare farm is 16 centimeter per minute. The field is to be irrigated when 50% of the available moisture in the root zone is depleted. So firstly, and everything else is given to it, is asking you the capacity of irrigation system, how much it is needed to irrigate the crop in 40 hectares. 85.1. How much we got? 85. Right. No issues. So, how much is the capacity of irrigation system? So, let's go part by part. Firstly, what it is asking you, irrigation is done when? Firstly, when we have to do the irrigation? When 50% of the available moisture is depleted, irrigation is done. When? At what time? When 16 centimeter per meter is there and 50% of it is what? 50% of it is what? Depleted. This is what it is asking. Anybody got the answer? No. Let it be then. I'll do it. 50% of it is depleted. So that means 8 centimeter. Now what it is telling me, next thing, this I did it. Now what it this I have taken into account. The irrigation water is to be applied by a pump working for 8 hours a day and water application efficiency is 80%. What do you mean by, and see, root zone depth is 1 meter. So that is per meter, that is 1 meter. Water application efficiency is 80%. Water application efficiency means water stored in the root zone of the crop divided by water delivered in the field. Why? Because there are runoff losses. That is the way you're not getting 100% efficiency. 20% is loss and you're getting 80%. So right now, water application efficiency is 80%. If the water, or basically the root zone, the depth which is required is 8 centimeter. So from the field, you have to do what? You have to supply more amount of water. If you need to supply more amount of water, that means what? More amount of water need to be diverted to the field. Firstly. Secondly, if you see in this question, consumptive use is given to you as 4 mm per day. So can you calculate frequency of irrigation? Can you calculate that? 8 centimeter, that is 80 mm, and this is 4 mm per day. So how much you get? 20 days. So the frequency of irrigation is 20 days. Fine. But this won't be the answer. Why? Because I have to calculate the capacity of irrigation system. How will I do it? Come on guys. I have to first bring from the irrigation system to the field. So how much water is delivered into the field? Water delivered in the field. How much? 8, which is the water stored in the root zone of the crop, and divided by the water application efficiency, which is 80%. How much it will call? 80 divided by 0.80, this will come out to be 10 centimeter. So this is the water which is to be delivered in the field. Now I have to talk about total volume of applied water. How much volume of water is to be applied? So total volume of applied water. How much it will be? 10 centimeter, and the area is 80 hectares. So simple. 80 hectares. 1 hectare is equal to 10 raised to power 4 meter square. You will get the total volume of water applied. So from here, how much it will come? Come on guys, faster. How much it will come? Check it out fast, how much it will come. Just a minute. Moisture holding capacity is given to me for an 80 hectare farm. And it is asking me for a 40 hectare. See, don't get confused. So right now we have to calculate the capacity. See, we have to calculate the capacity for 40 hectares. So don't get confused, okay? And actually this should also be 40 hectares. So this will get cancelled out, 10 raised to power 2. This will become 4234 meter cube. So this is the volume. 40 hectares it is asked. Yeah, I did 40 hectares. Rishabh, I did 40 hectares. Okay, so this is the volume. But in the question, it is asking me to calculate the discharge and that too in liters per second. That too in liters per second. So what do you have to do? Now, the main mistake which you guys do it. Total volume 1, 2, 3, 4 meter cube divided by 20 days. Now don't do 24. Why? Because the pump is not at all operating for 24 hours. It is operating for 8 hours. Come on guys. So what you have to do? First, if you take it as 24, 3600, okay, and this is 10 raised to power 3. This is liters per second. But this amount of discharge, you don't want it in 24 hours, you want it in 8 hours. So what you will do it? What you will do it? This you want it for 8 hours. What you will do it? Come on guys, faster. It is not asking me that I should give this discharge in 24 hours. They want me to get the discharge in 8 hours. So this much discharge I have to give it in 8 hours. Fast. So what? Don't write this 24. I'll write 8. That's it. That's it. Clear? Rishabh, Swapnil, everybody. So don't make this mistake, because never ever. You can take the example of your home. You guys also have pump in your homes. Do you operate it for 24 hours? Of course not, because it requires operational cost. Okay, you have to pay electricity. Similarly, it goes for the field also. You don't operate it for all the 24 hours. Okay, just check it out how much it is coming. 1, 2, 3, 4. 69.4444 it is coming. Yes, approximately. So this will be the answer. You can check it out also. Okay, fine. Now this, tell me, this is a simple question. Come on guys, tell me. Technically this is based on groundwater hydrology, based on porosity and permeability. Tell me fast. This is a very simple question, guys. You can do it. This is a very simple question. Already you know that sandy soil has high permeability but lesser porosity. Clay soil has more porosity but lesser permeability. Porosity means water holding capacity of soil. So just check it out. Sandy soil has lower water holding capacity. This is false, because clay soil has better water holding capacity as compared to sandy soil. But the permeability, ability of medium to permit the flow of fluid, technically in our case water, through its interconnecting voids, it is more for sandy soil. So the drainage aeration is high, but the water holding capacity of sandy soil is less. You can bring a clay, pour water, you will see that the clay holds the water. But if you talk about the permeability, it is poor in its permeability. So C is correct and D is also correct. This is an MSQ question. Okay. So Swapnil, C is correct as well as D is correct. Both are correct. Okay. Now, this question. This you have to tell me. This is not this one. This you have to tell me. It has asked the sodium absorption ratio. See, I haven't. There is another type of question which can be formed, and that question is different types of water is there based on SAR. Okay, so that also they can ask you. So everything you need to know. One more thing, if you just know the formula, that won't be enough. Why? Because remember, when you are substituting it, the units has to be in milli equivalents per liter, but right now which is given to you is in mg per liter. So sodium, if you talk about Na plus, it is given to me 345 mg per liter. So convert it into milli equivalents per liter, so divided by the equivalent weight, that is 23, you will get milli equivalent per liter. Similarly, you will do it for calcium, 60 divided by 20 milli equivalents per liter. For magnesium also same, 18 divided by 12 milli equivalents per liter. Solve it. How much it will come? 345 divided by, this comes out to be 15. This is 3 and this is 18. This comes out to be 1.5. That's it. Substitute every value. 15 root over 3 plus 1.5 divided by 2. How much it is coming? It comes out to be 3.06. So this, see, I have taken into account MSQ, I have taken into account 1 marks, 2 marks, every pattern of questions I am giving you, so that you should know the variety as well as you should able to solve such sort of questions if they ask you. Okay, next question. I think you guys can solve this question. Very easy. Very easy. Lastly, come on, no, D is, we're telling D for the last one or what? No, D is not the correct one. Why? Because currently also, if anybody of you like Swapnil, Rishabh, Devanshu, Raj, anybody can study it, like if you want to do PhD or if you want to make Raj's theory, Swapnil's theory. So let me tell you, still at present also the defect, see, Kennedy's defect was basically improved by Lacey, but still right now also there are defects which are present in Lacey's theory. Okay, it's not that it is completely eliminated. So if you guys want, you can also do a research work on this, that what are the drawbacks of Lacey's theory as well. Okay, so there are defects and it has written there are no defects, so that is incorrect. Other than that, 1 and 2 are the correct. See, if you are not able to solve, eliminate the incorrect one, you will get the correct one. As simple as that logic. This question, last question, this is very simple question. It has asked me the outflow at 1 hour. Let me tell you firstly the formula: C naught In C1 In minus 1 plus C2 Qn minus 1. So the outflow at 1 hour, C1 I naught plus C2 Q naught. So in the question, C naught and C1 is given to me, C2 is not given to me. D for sand question. What you are telling me? Oh, sand one you were telling me. Okay. Fine. Actually, there are 18-20 seconds lag is there in YouTube. What I say, you'll receive it at 10 to 20 seconds, something like that. So that is the reason you got it late. I got it late. 1 minus 0.06 minus 0.54. How much it is coming? 1 minus 0.06 minus 0.54. So it comes out to be 0.4. You remember this question, C0 plus C1 plus C2 has been asked in 1 marks in your GATE examination. You won't believe, but it is. And let us suppose if you get any Mussingham's constant as negative, don't worry, don't bother about it. But take the sign also into consideration. Okay, so this is 0.06. Now what is given to me? The inflow value at 0 hours. So at T is equal to 0, inflow is 25 meter cube per second. At T is equal to 1 hour, inflow is 40 meter cube per second. So this is 40. C1 is how much? 0.54. And what else C1 is? And I0 is 25. C2 is 0.4. And the outflow at 1 hour is also given to me. How much it is there? It is also 10. That's it. Get the answer how much it is coming. It comes out to be 19.9, and if it is asking you in the question round off to the nearest integer, it will become 20 meter cube per second. Correct? Got this? Got this? So yeah, we did it 9:51, around 9:50. We started it at 5. Yeah, so we did it in 45 minutes. We took the target of 30 minutes, but we did it in 45 minutes. Clear? Now there are more questions. Rishabh, Arun, everybody, girls, check it out. Missing rainfall questions. I guess you are aware with it. So normal annual precipitation questions and equilibrium discharge questions, transmissivity questions. Okay. So these questions, gravity dams questions is there. You can see it out. Then that formula is also there. T is equal to 2.303 y by f log base 10 q upon q minus fa. That questions are also there. Piping questions are there, then dilution technique questions are there, distribution efficiency questions, match the following, and the function of cutoff and all those things. Okay, so these questions are there, 15 questions. Those are the simplest topics which we haven't covered, which you can also do it. Okay, so ma'am, question 193. Question 193. Answer is not matching. Okay, fine, let me check it out. It is coming 10. It is coming 10. Calculation you have to do, but fine, I also do that calculation. It is coming 10. Okay? Yeah, correct. Correct, correct. See, the biggest problem with NAT is you write anything and you don't know whether it is correct or not. That's the problem with NAT questions. Okay. Clear? Any more calculation mistake, guys? You can check it. If any conceptual mistakes is there, then let me know. These are the questions, solve it, and if you ask me the solutions, then only basically the answers, then only I'll give. Otherwise I won't, because how could I know that you are sincere or you're not? Okay, and as I told you, scholarship test is going on, so you can register yourself. It is free of cost, and you have a session at 10:45 regarding the geotech formula memory test. You can attend that also, and let me know if many more sessions. Yeah, I promised you guys regarding the timetable. So in the next week, I'll provide you with the timetable. If you are a morning person, you wake up in the morning and study, or if you study late at night, I'll just give you a timetable that it gives you an idea. You can modify it as you want, but yeah, it will give you an idea how to execute your studies if you are following the wrong path or the wrong approach in your studies. Okay, so that's all for today, guys. Take care of yourself, and any doubts, let me know. So I'll share my Telegram group also if for any queries. That's it, and see you in the next lecture. Okay, that's it. See you in the next lecture. Till then, take care of yourself. Bye bye. Good night, and study hard.